Yeah, advantage of this GMC filter is it's an open loop architecture. You saw the integrator is open loop circuit, right? In the GMC, yeah, this a GMC integrator is only this one. And then this VO is just plus 1 over SC over GM times. So it is an open loop, right? In the active RC, there is a negative feedback, right? This is active RC integrator. In a switched capacitor integrator, we saw the same negative feedback by C, right? But GMC, it is an open loop architecture. So it is very simple. So it works at a very high speed. And so if I reduce the speed, we can implement it with a very low power. Yeah, those are some references. So let's just see, where is my circuit? Okay, I will come back this one later. So there are some circuit here, there. Okay, resistor, and then this is a low pass filter, and this is what? I think this is a second of the low pass filter, okay? This is a band pass filter. So we'll talk one by one, okay? This is inductor, something like that. Okay, any question until now? No? So we saw an integrator. Yeah, this is my GMC integrator, right? And then we can make a resistor. We can make a resistor. Then this is my resistor. My resistance is just 1 over GM. Okay, how come this is, sorry, it was wrong. Oh, this is not resistor, wrong. I made, my resistor must work like that. Okay, this is my resistor. So, the equivalent resistance looking forward, which is V over I, should be 1 over GM. Because, you know, yeah, the current is 0 here, right? Current 0. Current is 0. Then, because this is 0 volt, plus input is connected to 0 volt, then the current must going in like GMVI, right? So my current is GMV. This current must be same as GMV. So I can get my resistance is 1 over GM. Okay. If I connect them together, what happens? Say, for example, I have a capacitor here, and then I have a connect my resistance here. Yeah, what is this thing? Yeah, so this one is a resistor, right? 1 over GM. So my VO over VI is just plus a low pass filter, right? So there is a GM VI current flows in. This is a GM. No, this is positive, the current flows out, right? Then that current is multiplied by GM VI current is multiplied by that parallel combination of that resistance, right? So this is only what? I can say this is GM2. So this is a GM1. So this is a GM1 VI, 1 over GM2, 1 plus SC over GM2. Okay? So this is a GM1, GM2 times 1 plus SC over GM2. Okay? So it is a low pass filter, right? Low pass filter. Question? Because this is a very simple circuit, so actually there is some parasitic capacitance will be added here, right? Parasitic cap. We cannot eliminate the parasitic cap. Some very high-speed circuit, they use parasitic capacitance for this C. Yeah, mostly they use MOS cap here, this capacitor, MOS cap. Then they have a matching, okay? Okay, any question? No? Okay, let's look at the GMC integrator. Yeah, we said this, actually you see, let's see, plus minus, if this is VI, and then we implement GMC here, then, you know, the current must flow out, right? So that's a GMVI current flows out. It goes into here. Then my VO equal 1 over SC times this current. So my transfer function is so you know the magnitude of Bode plot of this one is just this one. So this is 0 dB, and this 0 dB frequency is only GM of C, right? We want to control this unity gain frequency. Then I need a matching between GMC and the C, right? If they match, I can control very easily. So if we implement this C by MOS capacitor, you know, this GM transconductor can be easily implemented by differential pair, right? Something like that. This is my transconductor. So I need some CMFV control or something, right? Yeah, this is my this is a differential version of my transconductor. So if this MOSFET is the same MOSFET as this MOS capacitor, maybe something like that, right? This is my C wheel. Then we can track the oxide variation, right? Oxide variation is eliminated by in this omega T. So we can implement the capacitor by MOS transistor. Question? No? Okay, then we'll go to the second order filter. Let's see, we'll go back this one later. Oh yeah, this is a low pass filter, right? Because I have one of GM2 resistor there. Okay, what is this thing? See, I have two integrators here, right? Yeah, I have one integrator here, and I have another integrator there. Oh, I have a resistor here, right? So this is a low pass filter, and then there is some feedback. What is this thing? Uh-oh. Okay, let's do it again. So this is my input. So let's just see. Here, yeah, this is my V out. So I have only 3 nodes here, right? Because this node is also V out, right? It's connected by this wiring. So yeah, we can derive some equations. So let's see. Yeah, what's the current flowing into here? Then my V2 equal 1 over SC1 times the current flowing in. That current is a sum of this one, minus GM1 V in. That's flowing out. How about this one? Oh, this is flowing out. That's flowing in. Yeah, this is GM4 V out, right? So those 2 currents are flowing into C1. And then how about here? Yeah, this is a low-pass filter, right? Say my V out is 1 over SC2. What's the current flowing in? Let's see. Yeah, that's flowing out. Minus GM2 V2. And what? Oh yeah, this current, right? This current also flows out. It goes itself. So is it, no, flowing in. So the current is flowing out. So GM3 V out. Okay? Any question? No? Okay. Then I can just substitute this V2. So equation 1, equation 2, we can substitute 1 into 2. Then my V out equal 1 over SC2. Oh, let me write it this way. GM2 times SC2, this is multiplied, right? Equal minus GM2 V2. What's GM2 V2? 1 over SC1 times minus GM1 V in times GM4 V out, right? This is, I substitute until here, minus GM3 V out, minus GM3 V out. So I collect all the V out terms here. So how can I collect my V out terms? I want to multiply this SC3, okay? Then my V out equal times S square C1 C2 equal minus GM3 SC1 V out plus GM1 GM2 V in minus, is it minus? Yeah. GM, let's see. This should be a positive, right? Not equal, positive. And then GM2, GM4 V out. GM2, GM4 V out. So if I collect all those V out terms, V out over V in equal only GM1, GM2, S square C1, C2, SC1, GM3 plus GM2, GM4. Okay? So I know this is only low-pass filter. Okay? Yeah, question? No? No question? So, you know, so we can convert this one into some form, some canonical form, right? That canonical form, this is a different thing. Yeah, the canonical form is this one. canonical form. This is my DC gain. Maybe I can say G. G? Yeah. Okay, so this G is my DC gain, right? The gain at the S equals 0. So you can find what's the omega 0 here? Let's just see. Do you remember that one? Yeah. 1, 2, 1, 2, 1, 2, 1, 2, 1, 3, 2, 4. Okay, is it correct? Let me check. Looks okay, right? Okay. So then see what's omega 0? Omega 0 will be GM2 GM4 divided by C1 C2, right? Something like that. Okay, that's my omega 0. And then what's my Q? Okay. Yeah, what's my gain? DC gain is just divided by GM1 over GM4. Okay, that's my DC gain. Then I can calculate the omega 0. Yeah. So my omega 0 will be omega 0 Q will be this should be 1, right? Okay. So this is C1 GM3 divided by GM2 GM4. So if I substitute the omega 0 there, my Q will be 1 over omega 0 times GM24 divided by C1 GM3. What's omega 0? Yeah, I can substitute this thing there, right? Square root C1 GM3, C1 C2. So my Q will be square root GM2 GM4, and then how about this C1 thing? C1 equals square root, right? Square root GM3. 1 over GM3 times square root C1, something like that. Is it right? GM is gone. Something wrong, right? I have a mistake in dimension. What's wrong? GM2, GM4. Oh yeah, C2. I need a C2. Is it, then it's okay. No, I need a ratio. Oh yeah, you're right. You're right. My Q will be square root C2 over C1, then GM3 square root GM2 GM4. Then this is dimensionless. Okay? Yeah, question? So it is if I take output voltage here with the input voltage there, then this is a non-inverting low-pass filter. Okay. So I used 2 integrators, actually 4 GM cells, 4 transconductance cells. Okay. Question. Okay, no question then. Yeah, what is this thing? I have an input here, and then I take output there. So I have two integrators, right? So I have I have a capacitor, two capacitors. So this should be a second order GMC filter. Later, we can implement this transconductor by inverters, okay? Just a CMOS digital inverter. We can implement this transconductor by a differential pair or by an inverter. Okay, okay, what's the function of this circuit? Yeah, I have, let's just see. Yeah, I have 3 nodes only, right? I have 3 nodes. Say this is the same as V out. Yeah, then I need 2 equations. Okay, so let's just see. Yeah, what's V out? Say I will calculate the current flowing into this C2 capacitor, and then let's just see. Yeah, there are 3 capacitors, 3 current components, right? This current flows out. And how about this current? Oh yeah, it flows out. How about this current? Yeah, it flows out, right? Yeah, this current is 0. Current is 0 there. So this current GM3 V out must flows in. Okay. Oh, should be negative, right? Oh, this is very weird. Negative, right? Is it right? Yeah, I think it's wrong. Yeah, let's make it negative. This is a negative, okay? Then it flows in. So it current direction must flows in, okay? Should be negative. This should be positive. Because if I connect the output node to inverting input node, it is resistor, okay? All right. So let's just see. I have a 3 current component. Let's just see. 2 flows in. 1 flows out. Okay. And then how about the V2? Let me calculate the V2. So my V2 equal 1 over SC1 times, yeah, what's current here? It has only 1 current component, right? This current is 0. How about that current? Won't be out, so it flows out, okay? Because this is positive. So this is GM4 V out. That current flows in. So this is GM4 V out. Okay? That's it. So I substitute V2, the equation 2, equation 1. Say I can calculate the V out. So let me multiply SC2 at both left and right terms of equation 1. So this is SC2 V out equal GM2 V2. V2 is only 1 over SC1 GM4 V out. Oops. Uh-oh. This is another wrong. Yeah, polarity. I don't like this polarity. Looks like there is some mistake in the polarity. So I will change this one into this. Okay? Then what the changes? V out. Yeah, flows in. Okay, instead of flowing out. Okay, then this should be negative. Okay. So I want to make this negative. Yeah, this is, where is GM2V2? Oh yeah, here. Okay. Then I can add a V out, right, with this one and that one. It must be added instead of subtracting it. Okay. Then GM5 V in minus GM3 V out. Okay. Yeah, I will multiply SC1 in both terms at the left and right, and then